Yeah, so very quickly, if we had to do 5 the other direction, we don't have to, but just... Here we go. We're not asked to find f of g of x, but we had the question, what if I had to find f of g of x? So that means I would be plugging in g of x, which is 3x squared minus 5x. And so that would look like, into function f, that's 1 over, where there used to be an x, I'm now going to put 3x squared minus 5x. That would be the composition. And then if I had to find the domain, we first need to find the domain of the inside function. That has no possibility of dividing by 0. That has no square root. So the domain of the inside function, g, is all real numbers. So that means the only thing I care about is the domain of the composition, which is here. It has no square roots, but it could divide by 0. So how can I make sure I don't divide by 0? We can say the denominator cannot be 0. And I could solve this by factoring. There's a GCF of x. That would leave me with 3x minus 5. Cannot be 0. Two things multiplied together to not be 0. So either the first thing is 0 or the second thing is 0. And if we solve here, 3x cannot be 5. X cannot be 5/3. So this has two problems with the domain. It can't be 0 and it can't be 5/3. So we could say the domain is from negative infinity up to 0, union 0 up to 5/3, union from 5/3 to infinity. So again, I'm going the other direction. I'm doing f of g of x. Wasn't asked, but if it was asked, that's what it would look like. Questions there? 6. They just wanted a verbal representation. What does C of S of 3 mean? Or equals 11. What does that mean?
Put 3 hours after opening. There are 11 shoppers in store.
That's it.
That's actually it.
That's it. So like if I look at the innermost function, if I plugged in a 3 to S, right, it tells me S of T, where T represents the hours after it's open. So I'm plugging in 3 into the hours after it's opened, and then I'm getting an output of 11 for C, and C represents...
Is it workers, not shoppers?
It is, you're right. C represents clerks needed. So it should be workers. So 3 hours after opening, 11 workers or clerks are needed. Sorry. Do we see why? What was I plugging into to start with? This was T for time. What was I getting an output for in the end? C for clerks. 7 similar, right? Same idea. So if I'm trying to find T of H of 40, I'm plugging 40 into H, which is taking the place of D, where D represented the number of days into the school year. So I'm going to be 40 days into school year. And then the output is all the way out to T. T represents the time it takes in minutes to complete the problems. that were homework, right? So 40 days into the school year, it takes 128 minutes to finish homework. Wow, there we go. Just found a composition. Oh, no, I'm just making it up. Okay, so here is f of x. Here is g of x. Why is it not putting this stuff together? I don't know what's going on. So if I had to find f of g of x, is this what you're talking about?
Yes.
Then that means I'm finding f of, and g of x is x plus 3, which means everywhere there used to be an x, I'm now going to put x plus 3. So just plug into the original f of x up there at the top. It's 3 times where it used to be x. I'm now putting x plus 3 squared minus 5 times where it used to be x. I'm now putting x plus 3 plus 2. So that's really the new step, is substituting in like that. Or say new. I think you've done these before. Are we good to there? And then it's all algebraic simplification. So, look, the way this is, I'm just going to go to the next. Look, okay. I want to link that. No, not that. How do I put stuff together? I don't know. Okay, I'm about to go to a new slide. So I had 3 times, was it x plus 3 squared plus 5? Minus 5 times x plus 3. Was it plus? So if I had to distribute, x plus 3 squared means x plus 3 times x plus 3. And then for me, I would go ahead and distribute here. Negative 5 times x is negative 5x. Negative 5 times 3 is negative 15 plus 2. Now, if I have to distribute on the left, I do the parentheses first. I saw on one of the tests that we did, there were more people than I thought should have. Like when there was 3 things multiplied like this, they distributed the 3 to here and the 3 to here. That's wrong. So if you want to distribute the 3 out front first, it gets multiplied by one of the parentheses, not both of the parentheses. But for me, in order to make sure we don't make that mistake, I would just distribute the parentheses to each other first, leave the 3 out front, do the 3 at the end. But if you don't want to do it that way, that's fine. But anyways, I had a flashback to grading those tests. I was really frustrated. Okay, here we go. In parentheses, x times x is x squared. X times 3 is 3x. 3 times x is 3x. 3x plus 3x is 6x. Are we okay with me doing all that at once? 3 plus 3 is 9. There's still the 3 out front. minus 5x minus 15 plus 2. Then I would distribute the 3. So that's 3x squared plus 18x plus 27 minus 5x minus 15 plus 2. Combine like terms. There's nothing like 3x squared. That gives 13x. 27 minus 15 is 12. Plus 2 is 14. Yes, because there's no divide by 0, there's no square root of a negative on either one of those. So let's fill out this table of values very quickly. So on the left table, if my function was f of x equals x squared, hopefully we know these values very quickly. If I plug in negative 2, the output is 4. Negative 1, 1, 0, 0, 1, 1, 2, 4. Right? I wrote those up a bunch when we were doing transformations of functions. So hopefully we know those 5 critical points. Now we've got another parent function. This is the square root of x. If I plugged in negative 2 to the square root of x, error. They said undefined. Right? It's not a y value there's not an x value we can plug in to find a y value. What about the square root of 0? Square root of 1. 1. Square root of 4. Square root of 9. It says, what do you notice about the input and output values from the two tables? So, look at the ones they have in common. So, here, input 0, output 0. And this was the same here, input 1, output 1. What about here, input 2 and output 4? But here I input 4 and got an output of 2. There's not one, but what if I put a 3 here? What would I get? And here, if I put in a 9, I got out a 3. So what could you say about the x and y values? They're inverses. Everywhere? Where?
When they're positive.
When what's positive? Yeah. The x and y's are swapped, but only when the x's are non-negative. Because 0 is included. So while positive is not, it's wrong, but it's just because 0 is also included. Do I need to write that down? The x and y values are swapped when x is greater than or equal to 0. It says graph f of x equals x squared. Okay, it says graph f of x equals x squared and g of x equals radical x on the axis provided. Using 2 different colored highlighters or pens, graph each function. First, let's graph f of x equals x squared. Well, okay. I know my critical points, 0, 0, 1, 1, 2, 4, 3, 9 is off. And then I also have negative 1, 1, negative 2, 4, negative 3, 9. Everybody good with that? Being x squared? Now it wants me to talk about the domain and the range. What's the domain of x squared? Do we understand that, or are we just regurgitating? Remember how, I don't remember if it was this class or my 6th period, I really got onto him about you never really learned domain the first time. That's why you don't understand the domain restrictions though. Anyways, okay. Okay, good, thanks. Next, range. What's the range of x squared? And 0 is included. Right, so bracket on 0, because it actually touches 0. That goes back to our non-negative. Right, including 0. Okay, now let's graph square root of x. So hopefully remember, we can't plug in anything for x unless it's non-negative. So if I plug in 0 for x, I get out a y value of 0. If I plug in 1 for x, the square root of 1 is 1. If I plug in 4 for x, the square root of 4 is 2. And if I plug in 9 for x, the square root of 9 is 3. And so right here, the graph of the square root of x looks like this. What's the domain of g of x? 0 to infinity. Including 0? What's the range? We good with all that? Next, draw a line that is y equals x on the axis above. What do you notice about that line? So you guys know how to draw y equals x? Yeah, it's a line with a y-intercept of 0 and a slope of 1. So it's going to go through 0, 0. I could rise 1, run 1. I could rise 1, run 1. Rise 1, run 1. Rise 1, run 1. Hopefully you guys can draw a little bit better than me. See if I can zoom in and it work. It is going to work. Thank you, thank you, thank you, thank you. Well, that doesn't help when the drawer's not any good.
You don't have like a line feature?
Nope.
I really don't know.
Yeah, it would. The only way I can draw a line, I can draw a oh. Well, that's new. Wow. That's so great. I give up.
It's perfect.
I give up. Okay. Yeah, hopefully you drew better than me. What do you notice about everything once you've drawn that line?
They all have a y-intercept of 0, 0.
They do? Okay.
They all go through 1, 1.
They do? Okay.
They all intersect.
One moves away from me. From like
Okay, yeah.
opposite direction.
Okay, yeah. What else?
Is there something specific that we're supposed to say?
Absolutely.
I'm not anything.
You know, I'm really fond of butterflies. Like,
Oh, they're symmetrical.
oh, symmetrical. Oh, symmetry. Oh, if I were to fold the blue graph over the purple line, I should get the red graph. Kind of? What's the problem there? They're kind of symmetrical, but there's...
It's the 0. The negative.
Yeah. So with the blue graph, when the x is negative, all that part should be ignored, right? So if I could exclude... Oh, no. Can I just erase the blue with that? Yeah, there we go. Sorry, I erased part of the... If I can exclude the part where x was negative on the blue graph, then I can see that these graphs should have perfect symmetry. That's why I was trying so hard to draw right through there. Right, and I couldn't get it lined up.
Wouldn't it be symmetry at the origin too? But you take out the other side?
Gosh, breaks my head.
That's Lindsay then. No, Lindsay's on. Well, you told us that.
I tried to teach you that, but I told you symmetry with origin like breaks my brain.
You just spin it.
Yeah. Oh, then yeah. Let's just say yes. I don't know if I'm right or not, but let's go with it. I had to do symmetry with the origin very algebraically. Like my brain won't let me see symmetry with the origin. But it is kind of like this. But it.
Just look at it this way.
The problem is to be symmetrical with the origin. I think that it has to flip to the other quadrant.
It's gotta be
Here.
odd.
That's what. Yes.
Yeah.
Yes. And these aren't really odd because it's not happening over here. If it snaked like that, it would be symmetrical with the origin. Or if this one was a cube root or a cubic, those are odd. But I don't know about because I'm restricting to only... I just don't know, okay? I don't know. Don't ask me. My brain. So, with this new function that I've drawn, think about the blue one. Its domain is no longer negative infinity to positive infinity. What's the new domain here? It's also 0 to infinity. So I'm having to restrict the domain to make it be symmetric about y equals x. So what we're learning here is anything that is symmetrical over this line y equals x, those are called inverse functions of each other. If I can draw the line y equals x and it folds over that line to map onto the other graph, then we have symmetry. And we have symmetry with respect to y equals x, and we know the two graphs are inverses of each other. There we go. I spit it all out slowly. Let's look at 4. It says let's build a composition function in both directions. So if I did f of g of x, that means I'm going to be doing f of, and this time g of x is radical x. So everywhere there used to be an x, there's now going to be a radical x, so that becomes radical x squared. What is radical x squared? X. Huh, cool. And then what if I went g of f of x? Well, that means I would be plugging in x squared to the radical, which would look like radical x squared. What's the square root of x squared? X. So f of g of x equals x, and g of f of x equals x. What did we learn yesterday about building compositions in opposite directions? F of g of x and g of f of x. They're not equal to each other. Not always, but they can be, right? Here's a special case where they were equal and they both went to be x. That's it. That's the ticket. So because they both equal x, when I build it in both directions, that means f and g are inverses. So here's what we're learning. If f of g of x equals g of f of x equals x, then F and G are inverses. Look how fancy that looks. But like, can you make sense of it? If I build the composition in both directions and both of them simplify to be x, then they have to be inverses. That's what we did here. What mathematical operation would you do to solve the following equations and explain why you chose to do that operation? So if you had x minus 2 equals 6, you would add 2. Why?
To get the x by itself.
Why? Or how did you know? How did you know to add 2?
Because you're subtracting two and you do the opposite.
Okay, so what's another word for opposite?
Inverse.
Yeah. So if we're going to get all technicality like, we chose to add 2 instead of subtract 2 because addition is the inverse of subtraction. Addition is, do I have to write this down? This one's going to be awful on here. I don't have enough space. Y'all just going to look. Just don't make me. Addition is the inverse of subtraction. That's what I'm trying to write. I know my limitations. It's got too many I's that look like colons, too little space. It's a disaster. Okay, what about B? 3x equals 7. How would you solve that? Divide both sides by 3. Why? That's it. Yeah, you got it. Now we're picking it up. It was really nice when we could do it with those easy peasy things. But now we're going to get into radicals. Oh. So if I had the square root of x equals 2, how would I solve the following equation? I would square both sides because squaring is the opposite of square root. And so that would tell me x is equal to 4. What about B? Square both sides. So if I square both sides, then that means that x would be equal to 4. So yeah, everybody knows if you take the square root of 4, you get negative 2. But
You get either positive or negative.
look at B again. If I take the square root of 4,
It's supposed to be x.
Wait,
equals positive or
but well, so
It's x.
so when I take the square root of a number, I'm saying what number times itself is 4. And so while you could say 2 times 2 is 4 and negative 2 times negative 2 is 4, because the square root is already written for us, does it have a plus or minus in front of it? No. So whenever they have the radical already written without anything in front of it, that means we're only looking for the principal square root, which means only the positive. Right? We don't have to do plus or minus if the square root is already written for us. So if I take the square root of 4, does that mean I get negative 2? No, I could only get 2, so what's the lesson here? Well, if I have a radical isolated on one side of the equation, and it's set equal to something that's negative on the other side, can I take the square root of something and it be negative? No, that's the whole problem. Because look back at our parent function, square root of x. Negative 2 is its output. So it's its range. Is negative 2 in the range of the square root of x? No. So this one is no solution. Because negative 2 is not in the range. Okay, what about C? X squared equals 9. So now what's different here? Was there a square root on the paper before? No. Who put the square root? I did. When I choose to take a square root, I must account for both possibilities. See the difference? If the square root's already there, it's only asking the principal square root. It's understood. But when there is no square root and you choose to take a square root, you must account for both possibilities, plus or minus 3. So again, it says you could graph these in your graphing calculator and see if they are inverses of each other. The answer is going to be yes. Okay, let's move on. Because I really need to get the next one done. So how do we find it? Kind of. Yeah, kind of. So here they go, step-by-step instructions. Given f of x equals x squared, it wants me to find the inverse. So here's the steps. First, we change f of x to y. Now, what were we doing when we were finding the inverse? Remember back to that original drawing. Used to, with the x squared, if I plugged in 3, I got out 9. But with the square root of x, if I plugged in 9, I got out 3. I'm really just switching the x and the y value. 3, 9 to 9, 3. 2, 4 to 4, 2. So that's what we do here is we switch the x and the y. And now we solve for the new y. So y is being squared, so I'm going to take a square root. So, where did the square root come from? Me. So when I choose to take a square root, I must account for the plus or minus possibilities. So get y equals plus or minus radical x. And so they want me to graph that. So this is kind of in two pieces. So do we know how to graph y equals the positive square root of x? We just graphed it on the page before, right? It looked like that. Do I know how to graph y equals the negative square root of x? Think about your transformations. If there's a negative out front, that's a reflection over the. Is it inside or outside? Outside. Outside affects the y's. So if I need to change the sign of the y, I'm going to reflect it over the x-axis. We follow all that? So the other part, the negative square root of x, would be here. What does that look like? Sideways parabola. But is it a function? It's not a function because it doesn't pass the vertical line test. And we don't like dealing with stuff that's not a function because that just is strange. So here's the bottom line. In order to find an inverse, the OG function, that's my wording, not theirs, must be 1-to-1. And people get this so confused all the time. Think about before I reflected it. This started out as x squared. And if I reflect it over this line, it's going to be this function. Well, it's not a function. It's going to be this relation. Where would it come from? It's a relation, but it's not a function because it doesn't pass the vertical line test. So, the point is, this is a function because it passes the vertical line test. But is it a 1-to-1 function?
No.
Do you know how to tell if it's 1-to-1?
No, I actually don't.
Go for it.
I said it passes the vertical line test.
Well, if it passes the vertical line test, it's a function. So this is a function, but it's not a 1-to-1 function. 1-to-1 means it must also pass the horizontal line test. Because think about what's happening. What did we say is happening when I find an inverse? I'm changing the x and the y's. So while every x used to have one y, if I'm going to find its inverse, I need every y to have one x. Because it has to be invertible. It has to be 1-to-1. So we can use the horizontal line test to determine if it's 1-to-1. Vertical line test determines if it's a function. People get them confused once they learn, but hopefully you kind of follow the logic. So what can I do in order to make x squared 1-to-1? I can restrict the domain. And now it becomes a 1-to-1 function. It passes the vertical line test and the horizontal line test. That's why we restricted it. Anyways, so let's start trying to do some of the notes. That's a lot of check your understandings. I don't expect you to do all. So we need to get both those done, and you now are able to do Canvas 2.4. So yesterday you opened up Canvas 2.3 to you. Now it's Canvas 2.4. If you remember, I told you right as we come back from the 9 weeks, it's going to be a little bit of a lull. It's going to seem like it's not as bad, and then it's going to hit you like a ton of bricks.
Okay,
Here it
so
comes.
How many can we do? 4.1.
4.1 should already be done.
Okay. 2.
That one was from the last test. 2.3 and 2.4.
I was doing 2.3 yesterday.
And starting Monday, we're going to open up Unit 4. 4.1, 4.2, 4.3. Those will start becoming available. So it's fixing to be, you got 5 Canvas assignments you're going to do before Thanksgiving. 2.3, 2.4, all of Unit 4. You've already done 4.1 though. So 4.2, 4.3, 4.4. But you can't do the other Unit 4s yet, but that's starting Monday. That'll become available. I'll have the other set of notes posted on the video if you want those. But it's all about a 1-to-1 function and horizontal line test.